Hello all, it's Ferdinand tutorial. Let's talk about buffers. A buffer is a solution which resists change in pH following the small addition of a strong acid or strong base. Now buffers are usually a solution which contain a weak acid and its salts or weak bases and its salts. Example of weak acid and its salt is, now let's talk about acetic acid and sodium acetate. They are buffers which contains weak acid and its salt. Now why do we term it a buffer? Why do we term a solution containing weak acid and its salt a buffer? Now, a weak acid that we're talking about is, let's say, CH3COOH. That's acetic acid plus CH3COONA. If you look at this solution, if you look at these two compounds, now you see this one here, this is acetic acid. This is what? Sodium acetate. Now, this solution is acidic in nature. One might ask, why is it acidic? Because you have sodium here, that's a salt. It is acidic because the Ka of this acetic acid, which is the acid, is greater than the Kb of this sodium acetate here, making the solution what? Acidic in nature. Are you getting it? And it is called a buffer because it contains a weak acid and its salt. Now we have another type of buffer where we have a weak base and its salt. A weak base that we are talking about, example, we have ammonia plus ammonium chloride. Now, if you look at this solution, ammonia plus ammonium chloride, they are a solution, they are a mixture. I get it. Now, you see that ammonia here is a base, ammonium chloride here is a salt, but this is a weak base, this is a salt. I get it. Now, this is called a buffer. This is called a buffer because they contain a weak base and its salts. And this solution here is basic in nature because the Kb of this ammonia is greater than the Ka of this ammonium ion. Now remember that there is an ammonium ion here. Are you getting it? That's why it is called what? A buffer. I don't know if you are getting it. Now let's take for instance, when we introduce a base to this solution, let's say that ammonium ion plus OH. Now if you look at this solution, what do we have? Ammonia plus what? Plus water. Now this water here, the presence of water will make the solution, that's the buffer solution, to be constant. Are you getting it? Now at this point now, we'll now see that a buffer truly resists a change in pH. Now following the addition of a strong acid or strong base. This is OH minus. Now that is it. Now remember, in the course of studying buffer, there are questions that we solve. And this question requires some mathematical operations. They require formulas. Now when we are solving for buffer, there is an equation that we use. Now the equation, we call it a Henderson-Hasselbach equation. Now this Henderson-Hasselbach equation, the equation is equal to pH equal to pKa plus log, we say salt over acid. Let us react an equation. Now let's say that a weak acid ionizes. Let's take this weak acid for example. It ionizes now to form H plus A minus. Now this H plus is a proton, while this A minus is a conjugate base. Are you getting it? This is an acid, this is a conjugate base, which you can also call a salt. Are you getting it? Now, let's react this equation. From this equation, we can prove that a Henderson-Hasselbach equation can be used, that it is equal to this, which can be used to solve questions concerning buffers. Let's go. Now, to find a constant, remember that we have constant is equal to product all over reactant. If you have the product which is H plus A minus all over the reactant is what? HA, concentration of HA. Now at this point we do what? We cross multiply. Cross multiply, we now have that we have H, concentration of H plus concentration of A minus is equal to K H A. Are you getting it? Now, having seen this, we'll divide by the coefficient of H plus, which is A minus. We want to make this H plus to stand alone. We divide by the coefficient of what? H plus, which is what? A minus. Now dividing, we now have that H plus will be equal to K HA over A minus. Are you getting it? Now at this point here, what do? We'll now add log to both sides. We add log 10 to both sides. Now, log base 10 to both sides. Now what do we have? We have log hydrogen ion will be equal to log K concentration of HA over what? A minus. Are you getting it? Now, we multiply both sides negative by negative 1, which is minus 1, minus 1. So multiplying both sides, we now have that. We have negative logarithm of H plus is equal to negative log K. Now remember, this thing is not different because this K is equal to Ka. Are you getting it? Since it's a constant of what are we looking for? We are looking for the constant of what? A. So we have log Ka, which is what? Log negative log HA over A minus. Are you getting it? Now at this point, we'll now add P to both sides. Now here we're supposed to have pH because pH is called negative logarithm of what? Hydrogen ion. pK is negative logarithm of Ka. Are you getting it? Now negative logarithm of anything is P of that same equation. If we have negative logarithm of hydrogen ion, is what? pH. Negative logarithm of Ka is what? pKa. So now we have that pH is equal to pKa minus log HA all over what? A minus. Now at this point we are not through, remember. Now we want to reverse this end equation to turn it to be a what? A positive equation. So what do? We'll now continue here. Remember, so that we have pH will be equal to now pKa. Now instead of adding negative, now we'll reverse the equation, or reverse the end part. I get it. We'll reverse the end part. So now I have plus log. Now it will reverse log A minus over what? Over HA. That is where we have, since we remember in our reaction when we are reacting, we say that HA will give us H plus A minus, where HA is a weak acid which ionizes in water to produce what? A proton of that acid and what? And a conjugate base. Are you getting it? Now, having seen this, remember this is a conjugate base. I said a conjugate base, which can also be called what? A salt in this field. Are you getting it? So now we have, anywhere we see A minus, we put what? Salt. Anywhere we see HA, we put what? Acid. Let's go. Now we have equal to pKa plus. Now A minus here simply means what? It is a what? Log salt all over. HA is what? Acid. This is what? Equal to this equation. This is what we call what? Henderson-Hasselbach equation. That means that we can follow this principle. Following this principle, we have proved that Henderson-Hasselbach equation is equal to this. Now we can use these equations to solve as many questions as possible concerning what? Buffer. Now, I would like you to do something. Look for textbooks, look for questions. Use this equation to solve as many questions as possible. If you encounter any problem, comment it in the comment box. Write your questions down, the one that you cannot solve. Write it down. We promise to solve it, give you the answer. Are you getting it? So thank you. That is all we'll be doing for today. I'll be hoping to see you in my next class. Please try and be there. My next class will be holding on Thursday. Don't forget, on Thursday, please try your best to be present. I love you. We love you. Please try and share to your friends who don't know about this tutorial. Tell them about what we are doing here. If you are really understanding, if you are really getting, tell them so that they can also be part of it. And don't forget to subscribe to this channel to be seeing our video, more of our videos. Thank you.